Okay, so the unit we are going to move into is all about radicals, which you all know as a square root, but there's more to it than that. This is actually called a radical symbol, and typically you do something like this. You say the square root of 4 equals 2, and the reason you know that is because 4 breaks down to 2 times 2. They're both prime, there's a pair of them, so that's the square root of 4. The other thing that I bet you don't know is that there is an invisible 2 in that little check mark part. We don't write the 2 because it's super common, so we just assume it's there. But the reason it's a square is because it's 2. So we can actually also do cube roots. And the cube root of 8, if we break this down, sorry, let me look at this like this. If we break this down to 4 and 2, our 4 breaks down to 2 and 2. And check that out. How many 2's do we have? Well, we have 3. So the cube root of 8 is 2. See how this works? Now, if we're dealing with a cube root, we write the 3 because, it's not the norm. The 2 is the norm. Guess what happens if we do the 4th root of 16? Well, if I break 16 down, I get 4 and 4. And if I keep going down to prime numbers, I get 2 and 2. And look at this, 1, 2, 3, 4 of them, just like there's a 4 here. And that gives me the 4th root of 16 is 2, because 2 to the 4th is 16, and 2 cubed is 8, and 2 squared is 4. See how this works? Okay, so these aren't actually called square roots like you've been calling them the whole time. A square root is when you have a radical and you're using the square root versus a radical with the cube root or a radical with a 4th root. They are all radicals. A square root is a type of radical. Okay, so there's that. Let's keep reviewing little things. Let's discuss what happens when we have something that's not a perfect square. So typically we look at perfect squares, like the square root of 9, the square root of 25. But what happens when we have like the square root of 32? So we can put that in our calculator and get a decimal on it. It's probably, 5.4 or something. I can estimate that to be, in the 5.5 or maybe 6 range, because the square root of 25 is 5, and the square root of 36 is 6, and 32 falls somewhere in between. So I'm going to say it's 5.6. Doesn't matter. That's an estimate. It's decimal. Let's break 32 down. Like, how else can I rewrite 32? I can say 4 times 8, right? And that should be equal. So the square root of 32 equals the square root of 4 times 8. And I can also write that as like the square root of 4 times the square root of 8. That should give me the same number. But look at this. 4 is a perfect square. So isn't that really just 2 times the square root of 8? It is. But oh wait, can I break my 8 down even further? So what if I have 2 times the square root of 4 times 2? Okay, so the square root of 2 times the square root of 4 times the square root of 2, and the square root of 4 is 2. Oops. Times the square root of 2. Now I just have 4 times the square root of 2. Whoa. Okay, so I just basically said the square root of 32 is the same as the square root, or 4 times the square root of 2. I bet if you put that in your calculator, you'll get it. So this crazy process we just went through right here to get to this is called simplifying. I know it doesn't seem very simple, but we just simplified this, and we took this from being an entire radical, because the entire number is inside the radical, to being what we call a mixed radical, because we've got a number outside and a number inside. Does that make sense? When they're written right next to each other like that, they're multiplying. So this says like 4 times root 2. And the way we say that is 4 root 2, or 4 times root 2. We don't always say square root of 2. We can, but a lot of times people just say 4 root 2. Now, there is an easier way to do that than this mess. Let me show you. I'm going to do this again. I'm going to take my root 32, and I'm going to go ahead and make myself a factor tree here. So 8, 4, 4, 2, 2, 2, 2, 2. So look what's happening. I've got, remember earlier we said the invisible number here was 2, which meant we were looking for pairs. So here's a pair of 2s, and here's a pair of 2s, and then I've got one solo 2 left. So because there's 2 here, I am going to take that out as a 2. Here's another pair of 2s. I'm going to take that out also. And then I have a single 2 left, and since it doesn't have a pair, it's going to stay inside. So 2 times 2 is 4, root 2. See how that works? Let me show you another example. What if I have this square root of 212? I'm going to break that down. 2, 106. Okay? 106 breaks down to 2 and 53. 53 is prime, 2 is prime. So I'm done. So here's a pair of 2s. Here's a 53. It doesn't have a pair. So I can rewrite that. There's a pair, so I take it out. The 53 has no pair, so it stays in. So 2 root 53 is equal to the square root of 212. Let me show you in my original way. 212 is the same as writing 2 times 106, right? 106 is the same as writing 2 times 53. Well, 2 times 2, that's 4, right? So the square root of 4 times the square root of 53, well, the square root of 4 is 2. The square root of 53 is not perfect, so I leave it inside the radical. But either way, I end up with the exact same thing, which is 2 times root 53. Okay, so again, mixed radical, entire radical. This process is called simplifying. I hope that makes sense. Okay, we'll talk more about this tomorrow.